Hello everyone. Um, Unity is loading. Hello, and it has loaded. So perfect synchro. Welcome to the next stream, where I'll be taking. I'll be trying to review the code of the RTS game that I worked on the game jam last weekend. And yeah, we'll see what has been done out there. Maybe I'll get some new thoughts about it. Oh, new release notes, that's cool. What are they improving? Name preview. Limit the number of open editors. Okay. Just a bunch of some other stuff. Cool thing about this project is that it has been written with the networking in mind. So the gameplay is actually split into the client and server parts, where server is an authoritative one, so we only trust server. Or as a client, we only send the input for the server. Server processes all of the data and returns back to the clients what has changed. But in reality, let me show you how the server reports that those things. So it just sends all of the data every frame, which is completely bad. It's awful, but we are trying to get it as quick as possible. As I mentioned yesterday, we haven't finished the project. I just finished writing the code for the gameplay. My friend finished writing the code for the networking, but we didn't have much time to integrate both of those things. So we ended up with just some knowledge, not a project, not a real game with the gameplay. But I think it's still cool. I learned a lot, and I will be happy to pass some of this knowledge to you just in a moment. And this would be most likely for now the last review of the ECS projects. The next thing that I will be focusing on those streams is just coding new stuff. So getting back to the project, applying some of the new patterns and the knowledge I learned by creating those two projects I shown you in yesterday and today. I'll be showing you. Because I think there's a really new cool stuff out there. So let's get started. First of all, let me go to the one of the scenes we created. Yeah, it's here. Whether it will work. I hope it would. If it wouldn't, let me switch to other branch that I remember worked. So it's let's try it out. So we made some UI for the hosting and joining, but let me just start the game. Okay, it's working. So we've got the unit. This is our unit. You can select multiple units by dragging them. Actually, let me increase the number of units that are spawning out here. There are not too many of them, just one right now. So server starter, player starter unit. So let's just iterate through it like dozens of times. Let's create like 20 units. Oh, my headphones are messing up with the keyboard. Okay, it's good now. Okay. And I would like to change the position of that, so let's give it like, and it will work. Just it will spawn 20 units. Is this plane big enough to hold all of them? I think it is. Let's increase that one. Okay. And we should have more units right now. Okay. So as you can see, I can select multiple units by dragging the rectangle on the screen. I can command them to move to some point. I can just click on certain unit, command create make him do something else. And the second thing is that I can command some of the units to shoot. So now, right now, they're focusing this guy, and when he runs from them, they're starting to chase him. But the animations are pretty awful for that, and they have to kill him. And obviously, you can target a dead guy, so like shooting a dead body. It's very dark. Yeah, but I can select all those 3 units and tell them, hey, execute this guy, and I can move the. Can I move the camera? Yeah, I should be able. Let me just go here and do it like that, and let's maximize it. So I can move the camera. Command those units to go here. Take those units. Shoot this guy. They're doing the job very well. There's no pathfinding out here, but it would be good to introduce some of that. But yeah, this is how it works. Just some simple RTS gameplay, prototype kind of thing. But thing is, it's all written in ECS, even this selection of units. So all of this logic is written in ECS. The only thing that's not is just taking what rectangle is currently selected and displaying it on the screen. So yeah, let's dive into it. Yep, so we can just see how it works. So just like yesterday, let's start from the components to see what they represent, what data we're operating on. First of all, we've got client camera, which is a single component, so it's like a variable, not really a component, and it stores a value for the camera in our scene for the client. Yeah, and as I mentioned, it's all split between the server and client, and there are some common parts of both of these types of execution, the game. Yeah, I know how to call it, the thing that client or server is, whatever. Later on, we've got the client controller, which is also kind of a variable, so it's a single component, and it's here where we are storing the creating a functionality for selecting some of the units. So as I mentioned yesterday, I wasn't very much I didn't like the idea of storing things like that in the input. So for me, it's good to split kind of a controlling thing of your entities into 2 components. First of all, one of them being the input. So as you can see, there's a client input which just collects the data from the mouse and from some of the buttons. So it's a very generic one. we're collecting some of the mouse input, and here move camera screen zone size and move camera speed. Just kind of a configuration of this input. And we've got a controller which executes some of the input data, so to call it. And in the controller we've got actions, kind of a concept I introduced. And only one action can be executed on one time. So as we've got selected units, that's just some kind of a property of our controller, but we've got the actions. First of all, being the select unit action. So this is this thing. So we get host, start game. So if I'm dragging, this is the action of selecting units. So of course we've got the states. So if this action is not being executed, it's in the non-state. But if we start to drag, it jumps into the selecting end screen position. So right now it's in the, most probably you can see that here, yeah. So if I start to drag, it's in the selecting end screen position. The start screen position is already set, and I'm just modifying the variable of the end screen position. And after I stop dragging, the end screen position is being set, and the value changes to done. And after the value changed to done, I can, in some of the systems, execute this action. So I know this action is well prepared to be executed, and I simply try to select all the units in this rectangle based on this data, assign it to the selected units, and after that I just simply change the state of this action to none, back to none, to be accurate. And of course this is a structure, and this is the variable holding the structure. So yeah. And moving on, we've got command units attack action. So I believe I can show it. I can show that to you too. So this was the select units action, command units attack action. So it works like we were trying to prepare for creating a user interface where you can just click on some button, start an action, and later on finish the action by clicking again on some part of the map, like you do, for example, in some of the RTS games. But what I end up with is just simply, if I click on the map with right mouse button, and it's the there are no characters on this point I clicked, then I simply execute the command units move action. You can see how quickly it jumps to the done, or you can see, whatever. But it simply sets the state to the done, sets up the target position. But most probably I can manually just click on that, selecting target position. Yeah, but oh, never mind. It's exactly, we haven't tested that, okay? So something might not be working here. But if I click on some other soldier, they are starting to attack him. So it sets up the target unit, sets the state done, and they are focusing on him, absolutely killing him. And we've also got move camera velocity, which is being set if I I need to increase the screen zone size, so let's say 20. So if I can set how much the camera should move, and the value of that is determined by the whether I'm on the edge of the screen, and it's calculated by some of the input systems, and the size of this edge is set out here, and this system just simply puts the move camera velocity, and later on the some other system grabs this velocity and moves the camera. so we get nice movement. All right. Uh, so that was all of those commands. Let's move to the inputs. Oh, yeah, I've touched the input already. Client state was supposed to store the current player ID, so we know which player are we in this multiplayer game. Client unit animator, so we took a very simple approach. So the animator, I mean the soldier or any other entity in the game is not animated through the ECS like I was doing on the streams before the game jams, which I still think is the great idea to do like that, because most likely the animation system for ECS will look like that. So you just give him some certain you can just set which animation should be played and at which time is it, which is a good thing to synchronize the animations with the gameplay. So animations are just representation of what's happening, not like part of the gameplay. But yeah, here we took a simple approach by storing the animator and setting some values for its properties on it. And I'm storing here last shoot trigger time seconds because we did approach that I can set a property in animator. Where's that model? Okay, I can set the property is shooting, and then he enters the shooting stance, and when I set the trigger shoot, he performs a shoot animation. So very simple one made in, let's say, in hurry. So I can finish that. Apparently we haven't. I mean, it works. I mean, the animation works. So we finished the animations, but the game haven't been finished. So yeah, let's move on. Client unit attack command. Okay. First of all, we need to touch on the commands. So as we have units, so there's a unit in our world. This can be a soldier. We are planning for units to be also like buildings. Some other movable units like tanks or I know, just whatever. And each of the units can have a command. So unit can have a move command or attack command, or base could have a build command, like you can build some barracks with your base. So it's kind of a structurized abstraction for the unit. And on the client, every unit has the client unit attack command, which clients uses to set if to use its the data in this component is sent from the controller. So if we are controlling, our controller says that those selected units are supposed to attack, those selected units are supposed to attack the target units. Then we are, in each of those units, we are setting the should exec, which is a shortcut for should execute, and we are setting this target unit. Move command works very similar, so instead of just setting the target unit, we are setting the target position. And the network is used for synchronization of the units throughout the client and server. So if a new unit appears on the server, we are sending the information about it with the preferred resources path, so it can be spawned on the client. And there's an ID, so we are tracking the instances of those entity network entities. We've got server state, which was used for something but ended up like as an empty component, so it's most probably not used anywhere. Server unit attack command and move command. These are reflecting components for those client attack command and client unit move command. The difference is that if we set this component on the client, what does the client system is doing? it's just grabbing this data, and instead of like really commanding this unit to attack, so doing some kind of a logic, we're not doing that on client. Instead, it's sending the I can show that actually. So command unit units attack. It's here. No, it's not here. Where's that? Where's that? Where's that? Client units attack command. Let me search for that. Send client packets. Yeah, it's here. So we are iterating over each of the network entities. I can hide that. Okay. We're iterating throughout all of the network entities for this component, which marks this entity shared by client and server. We're searching for the script. We are also checking for the unit ownership, so we are sure that this unit is controlled by us, so we can really send this command to the server. If the client, our client component says that this command should execute, then in reality we're just sending out packet to the server with the information about this command. And later on, the server does receive that packet, which is the queue in the system called the queue client packets, but in reality it's receive client packets. Messed up naming, but whatever. Receives all of the packets, and if it catches up the unit attack command packet, it iterates through all of the entities and tries to search that network entity. I think I should just create a function called find network entity, which would be much more simpler than iterating through all of them here. It's just some kind of a game jam fault out here from me. And if it finds one, so the correct entity that was supposed to attack, it copies the information. So it sets the true that this entity this unit should execute the attack command, and sets the target unit that was sent to him from the client. And I'm doing here some kind of a pretty cool magic by finding the network entity. So I'm not sending the ID of the entity because it can be different on the client and the server. I'm using my own target. I'm using my own network entity ID for that, which I'm by the way assigning here to make it matching the server entity ID. So pretty simple. Going back to the components, you know what they do. We get state, which is just like variable. We're storing here information about each of the player. We're storing the information of the cache for each of the players here, which is a wrong thing because the client should know, players shouldn't know, shouldn't be even possible for them to know which one of them has some cache. So it should be all of the cache values should be stored only on the server, but just whatever. Unit attack ability. So as we've got commands on the units, we've got the abilities and behaviors. So what does the command trigger is a behavior, certain behavior. So if we command our unit to attack, it triggers the attack behavior. So it makes this behavior active and makes all of other behaviors inactive. And just copies the target unit, or in this case the target position. And we've got some other variables here that are tracking the some kind of a processing of this behavior. So this unit move behavior was supposed to, like, this unit moves, and if it finds the enemy, then we are setting this found target unit. So later on in other systems we can make our unit attack this found target unit, but we never made it. I mean, it was not so much time to finish this functionality. So we got behaviors, and what does the behavior do is just controlling the ability. So attack behavior uses the attack ability and the move ability. So if the target is in the range, it's using the unit move ability to move to the target, and if it's in the range, it's using the unit attack ability to perform an attack. And later on we've got the unit health, the ownership which tells us which player owns this unit. The unit tag was just supposed to tag the unit that it's the unit, so the classic tag component. It's actually used in one place, gain unit from screen position. So if we're clicking and I'm doing a raycast, I'm trying to find through all of the raycast hits the hybrid entity. If I found one, then I am trying to search for the unit tag, and then if there's a unit tag, I know this is a unit and I can return it. Why not use some unit health or other, just to make it not assume, don't make an assertion that every unit has some component, right? Some certain component. So we know that, for example, the unit, that unit has the unit tag component. That's it. But we are not making assertion that every unit has the unit health component. It can have no unit health component. It could be like immortal or something. So we are not binding other functionality with just saying that this entity is an unit. So yeah. And in the unit team, so in the plans there was a plan to introduce 2 teams and many players. So there can be some players playing on one team, like Alliance, and the second team would be like Axis, Germans or something, because the game was supposed to be set up in the World War II reality. So yeah, that's it about the components. I see that some of new viewers joined. So just to quickly recap what's going on here, I'm reviewing the ECS RTS that I was coding on the game jam. We didn't do so much. We finished the gameplay, we finished the networking part, because we were writing our networking my friend was writing a networking from the scratch by using sockets, and we just didn't have enough time to join those 2 modules together to create a game, so we ended up with a gameplay and with a working networking. But yeah, that's whatever. We learned a lot, and that's the most important thing. So the gameplay works like that. You've got units. Oh my god, let me just change it here so it works every time. Yeah, maximize host, start game. Okay, so I can select the units by dragging on the screen. I can command them to go somewhere. I can move the camera by moving the mouse to the edge of the screen, and I can command the units to start attacking, start shooting. So they kill him. And if I command this unit to attack that one and he starts running, this unit starts to fall. Yeah, I know animations are broken, but it kind of works. The gameplay works. Let's get back to the systems. So for the networking purposes, I created the 2 structures, one of them being client packet, and it contains some information. So one packet can contain the information about unit attack command, unit move command, the assumption is that it does contain one of those values, not many, and it has the client ID. So who's sending this packet? And the server packet is like it goes this in the same way. We've got some of the things out here. Most of the packets being like sync, then it's like ability, sync unit move ability, sync unit health. So if anything changes, we're just sending a new packet that lets client know that something has changed. Right now it's done very poorly. I mean, just sending those packets because they are being sent every frame, which is like just awful. You do not do it like that. So I was missing time to introduce a way to limit sending those packets. So for example, I'm sending the sync network entity only the first time the entity spawns, or for example every 30 seconds, to keep all of those entities in sync if one of the clients misses one of the sync network entity packets, and of course when client connects. And for example the unit that was like sync transform, sync transform packet, it was supposed to be sent only like every 5 seconds or 10 seconds to correct the position, because ours you are simulating some rigid bodies positions on multiple machines. There could be a difference between in those simulations on those two machines, so from time to time you gotta correct them. Yeah. And what's next is those are sync unit move ability. So I was here syncing the target position. So it should sync only the time that target position changes, or the should perform changes. And so it's kind of a, I don't know how to say it, components that could be easily extended for this networking system. But yeah, let's move on. In the systems, and that's actually interesting because I was struggling how to put some functions, some common functions that would systems use. So we've got code systems in the ECS, but where do you put some of the functions, some common functions for those systems, so you don't have to repeat yourself? I was thinking about creating the base class with systems, but it shouldn't. I mean, I would have to derive from this class every time I create a new system, so that wasn't what I wanted. So I ended up by using the extension methods. So I write the extension method for the component system, so anyone can use it. I guess that was so some kind of a quick bug fix out here. So this was mostly bugged, and I just simply typed the return true here. Like whatever, let's not look at that. Let's take a look at the next extension method. So in many of the systems, I need to find an entity with certain network ID. So I create an extension method for that takes the entities from our component system, the entity network ID we're trying to find, and it just simply iterates through all of the entities. If it's fine, if there's found one, it returns it and it's done. And it's used by many of the systems, as you can see. I mean, to be accurate, by two systems. But by the DQ client packets and DQ server packets, but it's used in the many places here, like 9 references. So yeah, very nice reuse of one code. Get component object or null. So as I was mentioning yesterday, if you're executing this get component object on the entity manager, Turns out it throws an exception if this component does not exist on the entity, which is not what you would like to. I mean, it's kind of okay, but it's not very convenient to use. So I just create a function get component object or null. As the name says, it tries to get the component, but if there's no component, it returns null. And I do it by checking the has component before executing that, so I'm protected from throwing this thrown exception from this function here. And it's used in many places out here, actually. So it's also a good thing, good method. Get distance between entities. So yeah, really, you don't want to calculate the distance every time you do it. You want to have just function for it. So that's what I did. I have a function, I pass two entities. I'm getting the transforms from those entities, which is also an extension method. So this is a shortcut for get component object or null transform from the entity. I get those two transforms, I get this position, calculate the distance, and it's done. Also used in two places. So as I was using it, I will not go through all of those next extension method because their names are pretty self-explanatory. But as I was writing those extension methods, it turns out it's a cool solution, right? So I don't have to create some kind of a static functions. I don't have to create other modules or namespaces, some base classes for all of these systems. No, I can just create an extension method, and the best part of it is that I can create every extension method in its own file. So I don't end up with like a big file, big class, big base class with all of the, so to call it, there's a cool naming for classes like that. It's called utility or something. Personally, I don't like it. I prefer just to have one file per certain function. So it's like 34 lines of code, very small file. And it ends up being very convenient when merging the some of the branches in repository, because you just have a diff in one file. You don't constantly need to merge all of the big classes that contain a huge amount of methods. You just merge this one method. If something changes in this method, it changes only in one file, and that's it. And I found it pretty convenient. So when we will be getting back to our project from the first streams, I will most probably use this approach, so extensions approach for the component systems. And how do you use it? The only one inconvenience is that you have to write this dot. But, well, actually that's not bad, really. It works great. So yeah, we got a couple of those extensions. So we've got one extensions for all of the systems here. We've got extensions for the client systems and the extensions for the server systems. So those extensions make only sense on the server. These extensions make sense only on the client, and those extensions make sense just in every of our systems. Hello, Sergio. So, I don't know. Sorry, I don't know how to pronounce your name, but hi. So yeah, let's get down to the systems. First of all, very basic system perform unit. You move, we iterate over each of our unit that has unit move ability, unit health, and rigid body. Why unit health? Because we are checking whether this unit is alive. So if it's not alive, we wouldn't move it. And we are checking whether this unit move ability should perform. If it does, we are just doing some basic stuff to move this unit. I'm not going to dive into it because it's just some moving part, some pretty simple algorithm. And we've got two interesting things out here. So we've got client group and server group, and each of the systems in the server on the server has this thing on the top of it. So it says updated group, type of server group, and when I'm starting the client group, I'm marking it as a disabled, as well as the server group is disabled. So none of the server, neither the client systems will execute. They won't execute at the beginning of the game. And if I'm starting the game as the server, I'm turning those systems alive, so they start to execute. So I'm executing the server logic only if I'm the server. And if I start the game as the client, I execute those systems, only the client systems, so I'm not acting like a server, which is kind of a very cool thing to do, since we're not doing some unnecessary stuff. It's not complicated. Yeah, it's my project. I have been coding it on the game jam last weekend. I mean, it's hard to tell that it's a project. It's more like a code challenge, so to call it, because we haven't finished. It's not a game. I mean, it's something like that. It's just some very simple code stuff out here. So I can select the units. I can command them to move. I can command them to attack some other unit. I can command them to attack, and if some other unit runs, it starts to follow it. It was supposed to be a multiplayer game, but we didn't have enough time to finish it, so it's right now only kind of a gameplay thing with a network module that are not connected. Yeah, but the gameplay in ECS is kind of, I think it's ready for creating content and making some simple stuff out here. But yeah, getting back to it. So we have two groups of systems. I mean, three: a general one that works always, and the client systems and client and server systems as the separate groups, which only execute if the client if the game is currently run as a client or the game is run as the server. And let's see the server scripts at first. So I mean, not scripts, systems. So they assign entity network IDs, iterates throughout all of our network entities, and assigns the entity ID to the network ID. So it's necessary that we have some ID that is consistent over to ECS words on the client and the server, because if we spawn two entities on the client and on the server, they can have different IDs. And by creating a component called entity network ID and using the ID from that for sending the packets from the server or sending the packets for the client to server, whatever, using that in the network communication, we can be sure that we are pointing to the same entity that we are trying to point from the client to the server. So it's consistent between client and the server. The queue, client packets, I don't know whether we want to go for that. It's short system, so we can receive two kind of packets from the client, one to command our units to attack and second one to move. And we're simply iterating through all of the entities, trying to find the entity with this network ID that is pointed from the packet. It's here. And if we find one, we simply set the server unit attack command component to execute, which is later on done by the following systems. Same one for the move command. and exec unit attack command. So execute. I'm just typing like that to make the name shorter. We are iterating through the server unit attack command. Entities that have this component attached and have the unit attack behavior attached to it. And what we are doing is deactivating if our command should execute. We are deactivating all unit behaviors on this unit. We are making the attack behavior active, and we are saying, okay, this command is executed. Same one goes for the execute unit move command. We also deactivate all of the unit behaviors if this command should execute. We set the behavior properties and we mark this command as executed. So two simple things. And moving on to the processing of those behaviors. So one behavior can be active on the unit. So this is the attack behavior. We are trying to get all of the entities that have transform, unit attack behavior, and unit attack ability that is used by the unit attack behavior. I was trying to make some RTS on 2 1 year ago. That was so hard, but I want to return project when the ECS will be released ready. Well, man, you can start coding your RTS right now, as it's. You can code your gameplay in ECS right now. You won't get the perfect performance for it, as the pure ECS is lacking a lot of things. But you can code your game in the hybrid ECS. I mean the gameplay, and it won't differ too much from the gameplay that you would code for the pure ECS approach. So if you've got the time right now, it's not a bad time to start doing that. Hey Thomas, is it possible to code in ECS in French? Once again, you. This guy on the very first stream asked whether it's possible to code in ECS in German. Now he asked whether it's possible to code ECS in French. And no, man, you gotta try it. So let's get back to this unit attack behavior. So we've got all of the units with attack ability and attack behavior. We are checking whether this behavior is active. And okay, that's interesting. Why we are using here a unit move ability, but we are not trying to get it here? Because the attack behavior says, works like that it can use the unit move ability, but it cannot, it can use it, it don't have to. It doesn't have to have this move ability to work. So we get it from here, and later on, if it's available, we'll do something, but whatever. Let's get back to this flow of this behavior. We are getting the target unit from the attack behavior. We're getting its transform. We're calculating the distance between us and the target unit that we want to attack. We're checking whether this target is in the attack ability max distance. And if it's not, then we are not performing the attack ability. And if we have the unit move ability, we are saying, okay, now perform it and go to this target unit. So try to reach him. So yeah, it just moves our unit to the enemy. And otherwise, if we are in the range of attacking, and if we have this move ability, that we are saying, no, when you are attacking, just stop. You don't have right to move. And we are kicking off with our attack ability. And the attack ability is actually down here, so we are checking whether our character is alive. Pretty much the same as in the move ability, handling of the move ability. we're checking whether this target, this unit is alive, whether it should perform. I had some issues at the end with executing of that. It turned out to be a bad server client synchronization happening from my side, so I can just delete it. Yeah. And pretty straightforward logic here, like checking whether I can attack. So when would be the next time my attack ability would be able to execute. If it's not the right time, I'm just going past on that. And if it's right time, I grabbing the target unit. I'm actually checking whether my unit and the target unit are enemies. If they are not enemies, then I'm not dealing the damage. And I'm calculating the distance. So it's like double check on that. So behavior triggers something, but it's also protected by the attack ability. So if it's not possible to attack this entity from that distance, I'm just passing on that. And here I am calculating the direction for this target unit, and I'm using that to assign the direction. So move my unit to face the enemy. That sounds cool, right? Face the enemy. I'm picking the target unit health. I don't know. This is a big mistake out here. I shouldn't assume that this unit health component is present on the target. So it should be like target unit health y end. No man, it's like there's null. That would be actually accurate. Actually, I should rather do it like that. So just stop the flow of this system if it's null. So yeah, fixed it most probably. Yeah, this is how attacking works. And the last system here on the server, process unit move behavior, works very similar to the attack behavior, but here we're just using the move ability. It was supposed to also use the unit attack ability, but it turned out that there was no time, so it's only moving the unit. But in the design, it was supposed to like every time check whether there's a enemy target in the range, and if there is, it's not moving, it's attacking. So it's like attack move command, not just move. And here we are just checking if we are on the place, on the target position, if we're as a kind of protection, because it was kind of a bug that the enemy, the unit is like shaking because it can't reach the perfect float value of the position in the world. So yeah, that's how it worked on the server side. Yeah, it's recompiling because I made a change. Yeah, so just a quick review of those client systems, because there's not complicated logic out here too. So as we've got this controller component here, so this is our controller, client controller, player controller, just whatever. Got some things out here, and command units attack, grabbing the controller, checking whether attack action units attack action is done, so we are out to execute it. If it's done, we are just iterating through all of the units that are currently selected, assigning the should execute the target unit from this action, and we are saying that okay, it's executed, so back to the non-state, and it's all. Same way it works for unit smooth. Is it finally working in multi? No, it's not. I'm just reviewing the code. just only the gameplay. I haven't fixed that, Rix. Actually, Rix is the friend that was doing the networking. So we are working on that together, but we haven't time to combine our modules together. Yeah, moving on. The queue, server packets. It's just synchronization stuff. So it's a lot of code, but it's almost the code like find the entity with network ID and assign the values from the packet. So no reason to go over that. Handle controller command units attack action input. That's really awful name. Really, I hate it. I mean, it should be named kind of a better way. I need to find a way to got that. I haven't time. I'll watch in the record. Thanks for the content. Have fun. Thank you. See you there. And animations like 30 minutes using maximum. That's why they are ugly. Yeah, we had. We're like, okay, we have finished coding, but there's no time to create any content animations. Just nothing. Yeah, handling controller command attack units action input. So here we are grabbing our input and assigning it to the controller. So it's like processing all of the stuff from like if we're currently in the state of the selecting target unit, and if the left button is clicked, we are trying to find any unit on the screen position under the mouse. If there is one, we are setting it to done, so it is supposed to attack. And of course there's also as well a logic for right clicking, so if there's no controller action going on right now, we can just simply click right button and it would execute. Same goes for moving, but instead of grabbing the targets, so here we are trying to find the unit from screen position. If there's one, we are executing this action, and here's the opposite. So we are trying to grab the unit from screen position under the mouse, and if there's any unit under the mouse, we are not executing it. We are just executing, because here we want to grab simply the click on the map, catch the event where player clicks on the map, not on the units. And here we are moving our units. Here's pretty awful. I mean, it's not that bad, but it's kind of I wouldn't like to be that way in the final game, to be honest, because here we are detecting whether the mouse is currently in some of the screen edge, and if it is, we are assigning the move camera velocity, so we're moving the camera. Later on, this is the most cool one, I think. So select units action input. This is the most cool one, like really. So if we're in the state of none of this action, I mean, we are not in the state of none of this action, and we are currently supposed to select the end screen position. We are assigning this end screen position, and if the mouse button is not pressed, then we are done with that. So we have assigned this end screen position, and we are passing this this action to execute. And here we are, if there's no any action going on right now, and mouse left button is pressed, it hasn't been clicked, so it's a kind of a drag movement of the mouse. We're starting to select the rectangle, so we're assigning the current position of the mouse to the start screen position, which stays the same for the rest of the selecting rectangle action, and we are just assigning a screen position, so it's kind of a selecting only one point at the beginning, and we're changing the state to selecting end screen position, which later on works with that. And we've got the select units. So if this action is finished, then we are just creating a rectangle from all of those values from the controller, we are trying to search all of the units. I've got a nice function here, get all entities in string rect, just returning me all of the entities. By using the link, I'm filtering the entities that have the unit tag, so I know there are units. And later on, I'm filtering the units that are owned by the player, and later on just converting them to hybrid entity ref, so they can be displayed in the Unity editor in this hybrid ECS approach. Krzysztof Pięta, how does the process of creating new unit, assigning components and adding it to the entity looks like? So it is done out here in the server starter. So when I'm starting the server, I'm currently just, for each of the players, I'm spawning and 20 units of certain prefab. It's nothing, it's just basically the same as you do right now in Unity. Just instantiate some game object on the scene, and because of this hybrid entity script that is attached to it, and because every component I'm using is having this hybrid component is attached to it, it's adding it to the entity ECS world. So it's just like I'm using game objects, but I'm coding them like they were entities. So that's why it's called the hybrid approach. Most likely in some of the time I will upload those scripts, so this hybrid component, hybrid entity, and most likely this hybrid entity ref, because I mean it's the most cool one. So I can just assign the entity reference by let's just start the server. I'll show you. Let's host, start the game, and I can just assign any game object to the entity world as it was just a game object in the Unity. I have coded a simple property drawer here, which allows me to do it. So the workflow from the game object approach stays the same in this hybrid ECS approach. So where were we? Yeah, here, select units. So we're just selecting units here by creating this rectangle from the controller data. Oh, and if we are selecting indeed one point, so I haven't made any special logic for clicking, not selecting the rectangle. If we are clicking on one point, then I'm detecting that by checking whether the minimum value of x, so if the rect is just a point, then I am just using the get unit from screen position. And if there's no unit, I'm just assigning the selected units to empty array, not null. No problem, Krzysztof. I'm really happy to help. Read input just reads input from the input Unity engine input class and assigns the client input, so I can use it in the ECS world. Send client packets. That's a simple one. For each of the client unit move command, I'm sending the packet to the server. And actually, I think that briefly it's everything here. Just animating the entities by some data, and as I mentioned perfectly, it will be like executing the animations from here directly, setting the play times and other stuff, but we just use animator because it's faster right now. So I'm running out of time actually because I need to go. So I think that's all from this RTS review. I hope you liked it. If you have any questions, just leave a comment. I will try to reply to it. And on the next stream, we'll get back to coding. So just enough with the reviews of the game jam codes. And we'll start coding, and I'll start applying what I have learned to the code that code on the streams to the project that we have started. Hopefully creating something fun. Really, just to be honest, I'm really happy with this idea of the extension methods. So I was really struggling to find any real idea, good idea, where to put the command functions in the ECS, for the ECS systems. And it turns out that these extension methods are really cool. It just works. It turned out to be good for writing and good for using. So yeah, thanks everyone for watching. If any one of you have any questions right now, can stay for like about 5 minutes or something to answer them. And if you do have questions and you're watching this video as a whatever. If you're just watching this video, leave a question in the comments and I'll be happy to answer it. So yeah, just for the end, once again to show how it worked. Start the game, select units, point them to execute some random guy. The RTS ECS 3000 Cyberpunk 2000, what was that? Oh, never mind. I was trying to come up with a cool title for this project, but I failed at it, I guess. So yeah, as I see, there's no questions. So thanks everyone for watching. It's been a good time to do it for you. I hope you liked it. Yeah, and see you on the next streams. Bye.